All right, so we're back to, what is it, problem 9. What problem are we on now? Or 11? Oh yeah, the mixture problem. So we did the total value problem, we're going to do the mixture problem, and in the mixture problem we start out with the same concept. We have to account for the total amount of material. Just like we had the keys and the locks equal to 100, well here, the amount of 10% solution plus the amount of 70% solution has to be equal to 400 milliliters. So that part's the same. Well, now what about the percentages? Well, 10% of X plus 70% of Y has to be equal to 25, what are we shooting for, 25% solution? 25% solution of 400 milliliters. And that is the only variation to the total value problem. So it's the percentage of one component plus the percentage of another component is the desired percentage, but times the volume of the material. This is really telling you how much sugar there is you're getting from this jar, and how much sugar you're getting from this jar, and how much sugar is in the result. Okay, so the hard part is over. Now I'm going to multiply through by, what should I multiply through by? 10. I'm going to multiply through by 10 on the second equation. So I will have X plus 7Y equals 1,000. You're wondering, how did I do that? Where did the 1,000 come from? Well, a quarter of 400 is 100, but I multiplied through by 10. So X plus 7Y is equal to 1,000. But now the first equation says X plus Y equals 400. So now I have two equations and two unknowns. It's another elimination of subtracting one from the other. I'm going to subtract the second equation from the first equation, gets rid of the X, and I have 6Y equals 600. So Y, the 70% solution, is going to be 100 milliliters, and X has got to be 300 milliliters. Done.
Wait, sorry, we lost you back up at 0.1. What happened to that?
Here?
Sorry. I like to do it.
Oh, you mean back up to step 1?
Yeah.
Okay. Well, you're on board for the first equation. Okay. The second equation is we have to account for the sugar. Here we're accounting for the whole solution, the milliliters. But I need to account for sugar. The amount of X solution is 10% sugar. Therefore, this is the amount of sugar that's coming out of the X pot. This is the amount of sugar that's coming out of the Y pot. It's 70% of Y. I end up with 400 milliliters, that's 25% sugar. So sugar plus sugar equals sugar. So that's how you get to that.
I got that one, so I'm good.
What most people do is they forget that 400.
Yeah,
That's exactly what most people do.
Yeah.
And that's not a mixture problem. Right. The mixture problem, you're accounting for the thing that is in solution. Okay. From there, it was a piece of cake, right, Ernesto?
Yeah.
Okay.
This is
Okay, Cassandra, it's okay?
Yeah, I mean, it just seems so simple when you do it like that. So,
Well,
couldn't figure that
No,
out.
I really think that you practice this enough and you don't even have to think. If I had to think, I would be in trouble. So, no, I shouldn't say that. Mathematics is all about thinking. So,
I use the chart method that the last teacher taught me, and it works every time.
if you like that table stuff, go for
Yeah,
it.
it just makes sense to me.
It's what-
Because
That's
it just,
perfectly.
you itemize out, you have your, I don't know if you...
It's in the book, and you can use that method, and I'm all for it. And
Yeah, because it makes, for me, it makes it easier, because
That's
it's
good.
easier to remember.
Okay.
Because you're actually kind of playing out the whole scenario in, you've got what's going to be 10%, what's going to be 70%, and what's going to be your total. Then you've got, say you've got your one line item, your X plus Y equals your total. Then you've got your second, which is your percentages. x plus y equals, what your total is again, plus your, times it times your 400, so, or in this particular case.
Okay. If
However you get there.
that's right, and you would get full credit for doing the method that's promoted.
Yeah, until you get it, you have, it's increments of, whatever works best for the person, so that they get the concept.
What?
I asked you, where did that 6 come from after the x plus y is 400?
Oh, because I subtracted the two equations.
Oh, okay, go back to the top of it.
Yeah. And you can go back and watch the video.
Yeah.
Nice, huh? Okay, question 12. Consider the following equation. 3x plus 2y plus z equals 6. Okay, that is one equation in 3 unknowns, right? What geometrically is this equation? And the answer is it's a plane.
I remember the box, the 3-dimensional box.
It's a plane in 3 space. It's a plane in 3 space. Just like if I would have written 3x plus 2y equals 6 and asked you, what is that geometrically? You would have said, it's a line. It's a line in 2 space. This is a line in 2 space. That is to say, you can plot this. Right? For every value of x, there's a definite value of y, or you can go y equals mx plus b, and this would be a line in the Cartesian 2 space. But as soon as I introduce a third variable, it can't be in a plane anymore. I mean, it can't be in a flat space anymore, because I got 3 variables. Right? X and y, but and z's got to be someplace else.
You went over that too. That was at the end of it, before we had the test, like right at the
Right,
end.
and I went over that. So,
You went over
3 variables would be a plane in 3 space. If I would have written I wouldn't do this to you, but 3x plus 2y plus z plus w equals 6. That is an object in what dimensional space? 4-dimensional space.
So quad?
This would actually be a solid in 4-dimensional space.
Right, is there a name for that? Is that a quad or something?
No, this would be a
Just 4 dimensions?
solid,
So that's
solid figure.
a solid?
Yeah. This could be, a box, but it lives in 4-dimensional space. Too hard to comprehend, but...
Too hard to comprehend.
Right. Okay, so okay, so what kind of object? It is a plane. A lot of people said it was a triangle.
Well,
And
That's why I put, because you
I-
said 3 spaces.
I fear that this diagram that I made,
that's what you made, yes, that's why I remembered it.
there's a plane
Visual.
slicing through that, and if you slice through this, you get a picture of a plane. It's not
That was
very
in the
good.
book too, though.
You get a picture of a plane moving through that space. And maybe if I dash these lines to show that they're hidden behind that plane. Do you see the plane kind of,
Oh, yeah.
you see the plane, but a lot of people thought that was a triangle. It's not a triangle, it's just that these are the lines where the plane intersects the coordinate planes.
Oh, I can see that too.
Okay. Okay, question B. Does this equation, I'm sorry, does this object contain the origin?
No, because you had said that in when you did the little presentation.
But why does this not contain the origin?
Because it's around
What is the origin?
0,
0,
0.
0, 0. The origin is x, y, z equals 0, 0, 0. That's the origin. Okay, well,
Oh, this is 3x, 2y, and z. Okay.
so 3 times 0 plus 2 times 0 plus 0 does not equal 6.
Oh, I see.
It
yeah.
does not contain the origin.
I guessed at that, I got it right.
Okay. The object does not contain the origin. Okay. Does the object contain the point 1, 1, 1?
And I put no. I didn't think, because you had 3 and 2 and 1 equals 6.
Well, what we're saying is, the point 111 is x equal 1, y equal 1, and z equal 1.
Okay, so there'd be 3 times, it'd be 3, 4, 5, oh, I see, so it equals 6. I see.
So the plane contains the point 111.
I see, okay.
So that's all there is to question 12.